Hello, I'm Rob Hochberg. I direct the computer science program here at the University of Dallas. The main speaker today is Christian Aman, who is at Google, but I'm not going to introduce him. Yubkul will introduce him. I will introduce Yubkul and Brian McCutcheon. Brian graduated in 2017 with a computer science degree from the University of Dallas, and Yubkul graduated this past May, again, with a computer science degree from UD here. So let me just introduce them. They both work full-time at Google now, and I think it would be neat for them to just give us a quick overview of what it was like to interview, and what it's like to work at Google. And again, Yubkul and Brian will be speaking on their own behalf. They are not official representatives of Google giving official Google advice or Alphabet company advice. They're just going to be talking about their own personal experiences, okay? And then after their brief remarks, I would love it if you guys had any questions for them, and they'd be glad to field those. Okay, Brian and Yubkul, if you want to introduce yourselves, and maybe Brian, since you graduated 3 years ago, maybe you can go first.
Yeah, I'm Brian McCutcheon, and yes, I graduated back in 2017 with a degree in computer science and I guess a concentration in pure math. Been working in Google Cloud for 3 years, and I work in engineering productivity, which basically means that I build dev tools that are used by other Google engineers.
Hello, good afternoon. My name is Yavka, and yeah, I graduated from UD last year, and this year actually in 2020, and I'm currently working full-time at Google, but before that I interned twice in 2018 and 2019. In 2018, I worked in the Google Cloud team. In 2019, I worked in the Wear OS team. And this year, I started full-time with the Wear OS team. And what we basically do is building operating systems for different watches based on the Android operating system.
All right, thanks, Brian and Yubkul. Any participants, anybody here have any questions for them?
I'll ask a question. What was the most challenging part of your interview process? Let's go with Yubkul first. When you interviewed many years ago, so you maybe don't remember.
So yeah, I interviewed 3 years ago for the internship, for the first internship. And I say the most challenging part is being able to explain your thought process clearly to the interviewer. It's not all about solving the question, but it's also about making sure that the interviewer knows how you get to the solution. So that's a big thing to practice. Getting the solution will probably not get you the job because the interviewer needs to know that you know how to problem solve and how to communicate.
And to pretty much everybody, but I was wondering what both of your takes would be on this. If you could go back, what would you do differently? What would you prepare for, and how would you do it?
I can start. If I can go back, I will definitely start early. I started a few weeks before my internship interview, and that was not like really productive because I could have, luckily things worked out, but I could have highly increased my performance if I started earlier and did lots of questions, practiced a lot, and my confidence would have been much higher at that point. But yeah, I would recommend to start early, not to wait until you get the internship or full-time interview request. Start early, do questions usually, be active in your teams, be active in your schoolwork, and make it a habit to always learn and be willing to learn. And at the end, when you get the interviews, it will all be not complicated, not hard compared to starting slowly.
Yeah, starting early is good. I would add start early looking for internships. I found that it was really hard for me to get the first internship, but after that, like, things were easier, I guess. And yeah, and for internship, I see a question that says, how early should you start applying for internship positions? Some companies hire really early, like a lot of them hire in the fall or even like the summer before for internships. So if you're planning to graduate in spring 2021, now could be a good time to start looking probably.
if the earlier you go, the better your chances. Usually companies have an application window, and they publish that application window ahead of time. I know Google does. And so you can just look on their website and you can see when that window is for internships. For full-time positions, typically I would give it at least 3 months of time till you graduate to apply. I think applying much earlier probably doesn't help very much. For internships, usually they have windows when you should apply. Okay, let me seed another question. In terms of the things that you liked best about your experience at Google, what would you say would be like your most amazing thing that you enjoyed about Google? Yapka, you wanna go?
Yeah, sure. I mean, the biggest thing for me is to be able to work on services and products that maybe millions or if not billions of people that can use them every day. So knowing what you do every day makes that kind of impact is like a big motivation and a nice thing to have. And another thing, of course, is the people you work with. Everyone is willing to help you if you're new here. Everyone is so happy to answer your questions and make you feel at home. So those two things every day make me motivated to work more and hard.
One of my favorite things is the culture around testing and code health. There's a lot of emphasis on that sort of thing, and people care about it a lot. Yeah.
I have a question. My name is Clarissa. Could you just describe like what a typical work week is like for you guys?
Okay, Brian, you want to go first?
Sure. It varies, but there tends to be typically my day, I guess, involves writing code, reviewing code that other people wrote, attending meetings. We actually have a daily stand-up on our team where we just spend about 15 minutes talking about what we've been working on and what we're going to do. Just go around the circle and each person on our team says something. What else? Sometimes we conduct interviews and write interview feedback as well. That would be the main stuff for me.
Brian, would you say it's a 9 to 5 job?
It varies because it's very flexible with hours. I think back when I was in California, I did something closer to 10:30 to 6:30 ish.
Yeah, you usually have quite a lot of flexibility when it comes to your actual working hours, depending on when you like to start. And yeah, depends on your position, how much you actually work. It also depends a lot on you, how much you actually work. I think as opposed to a lot of other tech companies, Google doesn't typically force people to work crazy hours. There are some parts of Google that are probably worse than others, but typically you don't end up working a lot of hours. Yevka, any more comments on the workday, typical workday?
I think it's the same for the most part. Maybe one thing we didn't mention is talking to people. There are questions that come up, and even though there's a big infrastructure here to help you answer the questions that you have, it's always a good thing to know when and where to ask the question that you want, and to know the right thing to ask, to know the right person to ask makes a big difference. So as a new person, I spend a lot of time talking to people and like solving questions and understanding the code.
Great. Any more questions?
Hi, my name is Zainab. My question is what was the biggest transition that you had to face from transferring from a student to like a full-time worker?
That's a good question. The biggest transition I see is the amount of things, the breadth of your work expands like dramatically here. When you're a full-time person, you have to know what your team is doing and you have to know what other teams are doing in order to be productive. When you're a student, still we take different courses and we have to juggle different things at the same time. But here you have to be responsible and always be like willing to learn about what, not only what your team is doing, but also what teams around you are doing. So again, the interaction, the cross team interaction, yeah, that was like the biggest thing I can say so far.
I can go next. I think I would pretty much agree with Yabkal here. It's surprising how long it takes before you really become like fully productive, because there's just so much you have to learn and practice doing before you uh, before you have that basic skill writing. Well, that basic knowledge of like the subject area you're working in, but also that skill writing like Google quality code, I guess. And so, yeah, I think that would be a pretty big thing.
Yeah, I agree with. Yeah, I mean, for me, it's been a while. It's been like 10 years, but I think there's definitely what Yaka said is very strikingly true. I didn't even think about that, but yeah, when you work in a company, you have responsibility not only for yourself, but for a wide circle of people around you. You write a design document that somebody else might implement that has impact on somebody else's work in a completely different team that has impact on potentially millions of users. And so you go from being a student where you essentially are responsible for your grades and maybe for some group projects, you go to being responsible for a much wider range of things. And I guess the other big difference that I noticed for myself was that there is a lot of legacy stuff, and you have to figure out when to pick your battles and when to just accept things. That's, I think, something I found very challenging in the beginning when I started working was, oh, there's this old crappy system that nobody likes, but it's still around. It has been around for 3 years now, and nobody has ever like refactored it or rebuilt it or anything. And then people tell you, oh, well, that's because while it's old and crappy, it still works, and we don't have the resources to do anything about it. And then you say, but what if we did something about it? And then you kind of get into this idea of, oh, I'm going to go and fix it. And you figure out that actually the other people were right, and it takes you 5 years to fix it. And so in the end, you give up on it, and you learn the wisdom of, to some degree, picking your battles and figuring out priorities of things. I think when you're in school, you are confronted less often with challenging priority choices, I would say. That was a great question.
What do you think UD has done well in terms of CS, and what do you think it could do better?
Sure, I think UD does a great job of getting the CS fundamentals, but I think for students who want to go into software engineering, which I guess is kind of what this particular event is about, it's important to also get a knowledge of software engineering concepts, things like testing. Testing is huge, and just potentially design principles maybe, and stuff like that. Even just reading a style guide can teach you a lot about how code is written at a big company, I guess, at least to some degree. Yeah, that's my summary.
Okay, you want to go?
Yeah, I agree with everything that Brian said. I don't think it's specific to UD, but in classes and courses, as Brian said, testing is not a big thing. It's just making it work. But in industry, testing is a big thing. You might spend even more time writing the code to test than the time you write the actual code. So testing is a big thing that's different from education to industry, but UD definitely gives everything that you need to learn the basics and be able to be a good learner to learn whatever comes on your way.
Thanks, everyone. Okay, Yeah, I very much very much agreed. Testing is very hard to teach. I've no university program that I know teaches it, I guess, to the level that you need in industry. And that's, I think, it kind of comes with the fact that it's a computer science degree and not a software engineering degree. But I think these things can be learned. And I think the key thing is if you learn to learn in a way, if you learn to absorb new concepts, and if you're willing to understand things that you're not familiar with, if you're willing to investigate, then that sets you up for success in the end. So yeah. I'm gonna just go ahead and answer the two questions. One from Benedict. Actually, no. One from John. Are you guys working in person? Nope. I don't think, and I mean, not, I don't think I'm actually working in person, at least among the software engineers. We have some people, for example, the test drivers for the automated car at Waymo, they went back to work, quote unquote, because they can't work from home, of course, as test drivers. But the vast majority of people, they don't work from home. And we are going to go back to the office maybe middle of 2021, I suspect. But it's still kind of up in the air. The thing is that there isn't really a strong need for us to work from the office, so it's very hard for leadership to justify potentially getting people sick if there's no great need for people to actually be in the office. Okay, and then a question from Benedict. Favorite programming language used by Google? I think this is something that you can have a long discussion about. I think in terms of lines of code, it's probably C++. The divide that I've observed in the past is that people write large, high traffic backend services that don't have a ton of business logic, but deal with a lot of database layer and stuff like that. They write that in C++. They write application front ends typically in Java, and they write tools typically in Python. That's my feeling for how things are distributed, but I can't really support that with any objective numbers without actually looking into it. Okay, and then there's one from Sri. I think that one might be good to answer for Yapka or Brian. Maybe let's go Yapka first again. Is there a lot of on-the-job training that happens coming into the company? Yapka, you go.
Yeah, so I think this depends whether or not you were an intern in the past. So if you are not an intern at any point, there definitely is an extensive training that you get for several weeks for you to get familiarized with the infrastructure there, to write the code you need, to do code reviews, and everything that you need to be productive. If you were an intern at some point, this is like much reduced. I was an intern twice, so I had no formal training, but again, informally, you learn every day from the team meetings that you have. People come up with things that you never heard of, and it's your responsibility in a way to go and ask the people in charge to understand what that term is, what that system is, what that product is. So in addition to the formal training that Google gives you, you also have to be responsible in your own learning and always look forward to ask and learn every day.
Brian, anything more to say about that?
Yeah, I would say that a lot of the on-the-job training kind of comes in the form of written tutorials in my experience, which we call code labs. Other than that, we have a lot of it comes from sort of learning from coworkers through code reviews, especially coworkers who are really familiar with a specific programming language. And we do have like other internal courses and stuff like that you can take, but those are the main two ways I've learned, at least.
Okay, thank you everyone. Feel free to add additional questions and then we'll eventually answer them, maybe at the end or otherwise just via email. And I think Yapka was going to introduce me, I believe. So let's switch to Yapka, and then Yapka can introduce me.
Yeah, it's my pleasure. So our speaker today is Christian Amon. He studied computer science and computer engineering in Germany before he joined Google in 2015 in Munich. And since then, he has worked in the Munich office in Germany as well as in the Sunny Valley and Mountain View offices in the US. He's a very experienced engineer as well as a great leader in his team. And I had the privilege of working with him 2 years ago as an intern. He was my first intern manager. Christian is also a person who's passionate to share what he knows with others. He taught an introduction to programming course in Virginia in Hampton University in 2018, and he also shared his strong interviewing experience with us by giving talks in 2018 and 2019 in UD, both virtually, on how to do well in big tech interviews. So he's with us today for a third straight year, and before giving the stage to him, I would like to personally thank him, and also on behalf of UD, thank him for being willing to give this talk again for the third time, and I'm sure all of us have so much to learn today. So saying that, I would like to leave the stage for him, and everyone enjoy and learn from this talk, and please welcome him warmly.
Well, thank you for that beautiful introduction, Yapka. Okay, so we'll get started. Okay, so I'm going to do a little talk about interviewing for tech jobs. And this is most of it is actually not very specific to Google. This applies to any tech job, no matter whether it's one of the big fancy companies or it's a smaller engineering company. It always helps to have this prep, because in the end, most tech companies kind of copy the interview format that Google and Amazon and Facebook spearhead or kind of invented, so that the interviews will look pretty similar independent of which company you interview with, except that for some companies, small companies, you will probably have fewer interviews. So a few more things about myself. So this is me, beautiful, in Iceland on a little vacation. 2 fun facts about me. I don't own a car. I haven't owned a car for many years. Living in the Bay Area, that's actually not such a big thing, and I'm a big proponent of cycling, so I bike basically everywhere and use a car share car quite rarely when I actually need to. Another fun fact about me is that I actually used to work at Google. I left in the beginning of 2018, and I didn't work for Google for 10 months, and then I came back at the end of 2018. I left as an engineer. I came back as an engineering manager, but I was kind of doing that job before already. So now I'm an engineering manager. I manage a team of folks that work on service accounts for Google Cloud Platform. Service accounts are accounts that can be used to trigger automatic interactions. So let's say you have some backup job on your machine and you want that to back up stuff to Google Cloud Platform, you would use a service account to authenticate to Google Cloud Platform to do that. So another fun fact, or maybe not so fun fact, depending on how you look at it, that actually has something to do with my interviewing career is that I interviewed for Google twice. I came out of my master's degree that I did in Germany, and I applied to Google and I applied to a bunch of other companies as well. And in the end, I got to the on-site stage of the Google interviews and they decided not to hire me. And then I worked for a year for a smaller German IT company and then applied to Google again. And the second time it actually worked out. So one thing I can let you know is that it doesn't have to work the first time. And if it doesn't work the first time, it doesn't mean that you don't have what it takes. For me, mostly the biggest difference between the first time and the second time was that the second time around, I did a lot of prepping. I spent a whole week full-time prepping for my coding interviews, and that in the end produced the success that I had afterwards. But really, prep is super, super, super important. As Yapka has said, if you prep early, you will have a less painful experience. If you choose to prep late, then you will have a more painful experience. That's just how it is. I know that most people will prep late, but at least give yourself 2 weeks of full-time time to do your interview prep. Take 2 weeks off your job if you're applying when you have a job, or take 2 weeks after you finished your master's or bachelor's thesis or your coursework to just do interview prep. Or alternatively, you can spread that over the year or two before you apply, but I know that realistically many people won't do that, so yeah, you need time to prep for interviews. And interviewing as a skill, it is quite different from all the other things that you do during your courses or even during work. Okay, this one we already did, so let's just jump over this. Good, so what I'll talk about today is 3 things: what we look for at Google, how to prepare, and why practice makes perfect. I think I kind of already talked about that. You need to prep for interviews just the same as you need to prep for other things. Okay, so what Google looks for is fundamentally pretty much the same as what other tech companies look for. For interns specifically, we look for some amount of coursework, completed coursework that you should all have. So this is not going to be any challenge for you. We look for proficiency in some programming language. Proficiency sounds very challenging, but if you can get yourself through some interview questions, then you probably have the level of proficiency that you need. We don't care about your programming language. It says preferred here. Effectively, you can come with any programming language, and as long as it's not something completely absurd, your interviewer should be able to help you with that. And one thing that people kind of forget for interviews as well as for full-time is we also need you to be able to think about test cases. We need you to be able to think about cases where the input might not look the way you might want it to look, your code might want it to look. The complex problem solving is a bit, it depends on the level of internship. For first year and second year students, typically the level of problem solving is not highly complex, so don't let that deter you. For university graduates, we actually expect you to be able to code at a pretty good level, and in the end, the interview questions just get harder. So if you grab yourself an interview question book and you can solve most of the problems in that book, let's say, for example, cracking the coding interview, you can solve most of the problems in that book, you're probably reasonably well prepared. And yeah, industry level software engineering experience. This is definitely helpful if you've had internships before. There's nothing like practice to prepare you for life. And the thing is, you don't know what you don't know. If you have never done an internship, it will be harder to get into a full-time role, just because people will ask you stuff in interviews that you never had to worry about because you never had an actual job writing code as opposed to just writing code at university. Good. I think this is it. The usual caveat: currently the hiring situation is bad, as in there's essentially very, very few open positions at Google and at many other companies. The things that I'm talking about today, they apply to other companies as well, and there are quite a few even larger companies that are still hiring more than Google currently is. So if you don't find your luck at Google, try your luck at Facebook or Amazon or Microsoft. I think Facebook, Amazon, Microsoft are hiring more currently than Google is. For what I would generally recommend is get an internship as early as you can, because the internship interviews are easier than the full-time interviews, but once you get an internship and you do well in the internship, then you have a pretty good path to full-time. If you want to get into a full-time role after graduation, it's a lot harder than getting into the internship first and then just progressing into the full-time role eventually. Okay, yeah, so currently Google hiring situation is not great, but we're not the only company in the world. Okay, let's do some questions about the Google specific things. If you have anyone?
I have a question. So this is William. I asked the question in the chat earlier. How does Google view research experience versus intern experience when it's kind of judging a candidate?
That would be a good question for a recruiter because they do the initial resume screening. I would suspect for new grads, they would not care a huge amount about, or they would care less about research experience than about internship experience. That would be my initial feeling.
Okay, thank you.
Thanks. Other questions? What advice do you have for internship applicants without previous work internship experience? Oh, so for internships, you don't need to have a prior work or internship experience. What I would recommend is do a resume clinic with your career development folks. I think Christina is one of the career development folks, or the student center or whatever resources you have, and figure out what sets you apart from other applicants. Do you have any kind of nonprofit work that you did? Do you have any leadership roles in university organizations? Do you have leadership roles in university organizations? The earlier you get started on these things, the better. And these things definitely help to get you through the resume screening. So the more of these kinds of things you have, the better, I would say. Yeah, so you can talk to your career center. Shannon posted a few things about that. Yeah, what I found doing, I've done a few resume clinics when I was teaching at university 2 years ago. What I found was that typically people have actually a lot more stuff than they think about. Like I don't know, you were captain of the football team, or you were like the lead in your school theater play or whatever. There's usually plenty of things that at least give some evidence of your leadership characteristics. Your actual coding abilities, they usually are determined based on the coursework that you took and based on the grades that you got in that and based on the interviews eventually, if you get through the interviews. But what they look for in resumes for internship applications is typically leadership and citizenship contributions. And of course, prior internship experience if you have it. But otherwise, there's lots of other options. Okay, any other questions? Okay, Clarissa asks, do you have any book or website suggestions for good interview question practice problems? Yes, Cracking the Coding Interview is still the primary book to use. I used that when I applied and it's been getting updated continuously. I'm sure that there is one somewhere in your library, or you can just buy it, or you can get it probably from Dr. Hofberg. I'm sure he has one of them, or probably a few of those. Okay, so let's move on to our practice questions. We have two brave volunteers who volunteered to do practice questions with me. For everybody else, please take out a pen and paper and actually participate in this, because you're not gonna learn if you just listen to it. I can tell from experience. reading coding problems and reading the solutions. It's very easy. It requires no investment in terms of work, but it also doesn't produce any noticeable results. So let's follow along with this. I'm going to present the problems and we're going to talk through them step by step, and the volunteers are going to do that part of talking through them with me. But I will give each one of you some time to think about the problems yourselves and try to figure out if you can find answers to them. Okay. So the first problem is you get a list of integers and we want to figure out the second largest element in the list. I'm going to give you 1 minute to just think about clarifying questions that you might have. And then I'm gonna ask my brave volunteer. By the way, brave volunteer, what is your name?
Andy.
Andy. Okay, well, hi Andy. Thank you for volunteering for this. And after a minute, I'm going to let Andy ask some clarifying questions that he might have. And then we can go on to the next step. This is generally this system for coding interviews. You look at the question and you see what is currently unclear, what do you need to handle, are there any special cases, do you need any help from the interviewer before you can start. 40 seconds. Okay, I think that was enough time. Andy, are there any questions that you would like to ask on this?
Yeah, so you said we're going to get an array of integers. Is that like just a regular array, or is it a certain type of array list or anything like that?
That is entirely your choice. Feel free to pick whichever you want.
And with this, what kind of range of numbers can this be? Can it be like negative numbers, irrational numbers, anything like that? Is it just positive integers?
It's just integers. It can be positive or negative integers, but it's going to be integers.
Okay. Yeah, I think that's it.
Okay, good. So let's go on to step 2. And I'm going to let Andy start writing, and you can go and on your piece of paper, you can write down the method header. Basically determine what are the inputs and outputs of this method. Yes, I would like you to start writing the method header, and I would like everybody else to start writing the method header as well.
Okay. I guess I'll do this in Java, because I'm probably not the best, but I would probably do a static method, which would return an integer called.
Let's give the other people also an option to write down. So maybe do that quietly. Just write down the method header, and then everybody else can compare it to what they have. Okay, so we have a candidate for a method header. Anybody other thoughts on why this is right, why this might not be right? Good. I agree this is probably a good idea for a method header. And then let's think about our algorithm. I'm going to let you, I'm going to make everybody sit through a minute of silence while we figure out our algorithm, because otherwise people might not actually do anything. So I'm gonna set the timer for a minute, and then after that, Andy, you can start writing, and everybody else will hopefully start writing right now. Okay, I think that was a good minute. Andy, actually, before we start writing, can you just explain briefly what you think your algorithm would look like?
I was thinking I would put some sort of, I'd probably, define 2 variables, one being the second biggest and one being the biggest, and then go through the array or list and redefine the biggest variable whenever I find a bigger variable, number or integer, and then define the second biggest as the previous biggest value that we had. so that the second biggest at the end of the iteration, the for loop, will be the second biggest in the list.
Okay, that sounds like a very nice approach. Let's do that.
Okay.
Go for it. Everybody else, please also write down your solutions. But Andy, you go for it.
Okay. Should I write it down while explaining, or should I?
Yeah, please talk me through what you're writing while you write.
Okay, so I'm going to define the two variables first. So one will be called second for the second biggest, and I'll just make it the first item in the list, because I don't know what's going to be in the list, so I want to just use an item that's already there. And then the first biggest will be called the max, and I'll just make that the second item. And then after I have these, I'll do a for loop for some I in the list. And then in the for loop for each I, I'll see if the I is greater than the max. And if it is, I want to redefine the second as the previous max, and then redefine max as I. And then I guess after that, the second should be the second biggest in the list, because it's gone through every item and redefined it. So I will just return the second. And yeah, that should be, that's the integer, so I'm gonna return as the second biggest in the list.
Okay, so this is actually an important point to make. Whenever you find yourself saying this should return the second biggest or this should do X, let's do a test run to make sure that it actually does.
Okay.
We can figure out if you're speaking the truth or if you're lying to me.
All right. So you want me to make my own test case?
Yep.
Okay. So I'll choose I guess a simple test case, just 3 items. So I guess I'll have the list here as 3, 1, 2, just 3 integers. So when you call this function on this list, it will define second as 3, because it's the first item in the list, and then max as the second item. And then it'll go through the whole loop. So the first I in the list will be 3, and then it'll check if I is greater than the max, which it is. So max will be redefined as 3, and then second will be redefined as max. So I guess second was redefined first. I should have done that. But the second will be redefined as the previous max, which was 1, and then max is redefined as the current element we're on. So we redefine as 3, and then it'll go through 1 as I, because this is done, and then it will check if I is greater than max. Since 1 is not greater than 3, it won't do this part, and it will continue to the next item, which will be 2. And it will check if 2 is greater than max, which it is not. So, so I guess actually in this case, this is not true, because if I is 2, it's not greater than max, but at the same time, second is not going to be redefined to this integer, which actually is the second biggest in the list. So I guess my answer needs to be modified. Am I able to change my answer right now?
Sure, go ahead. This is actually part of the learning process. This is actually a very valuable experience that we tested our solution and it didn't work.
Yeah.
And you should always be suspicious if your first solution actually works, because usually that means that you're not testing right. Usually, whenever I interview candidates, I've done, I think, probably 50 interviews now at Google. Whenever I interview somebody and they write down a solution, I think maybe in those 50 interviews, I've seen it 2 or 3 times that somebody actually wrote down the absolutely correct solution. But the other 47 times, they wrote down a solution that had some mistake or another. And the testing is super, super important to actually figure out where you made your mistakes.
Okay. So yeah, I guess the problem here is that there could be something in between these two that won't get compared to the second.
Mm-hmm.
So I think if I erase this for a second, if I put in another test case, and then, so this is for the case where there's something in between that max and that second, and I want to compare it to the second biggest. So at first we know that I is not greater than max, but we also want to know if it's not greater than the second, which would mean it would be in between max and second. So if I is greater than second, then in that case, I want to redefine second as I. And then that should solve the solution when solve the problem of having an integer that's between these two things that comes after the two integers that are currently defined as second and max. And then since I've kind of resolved that, I think now there should be a correct answer, but I'll do the test. So for this one, the problem that I had was 2 was not being compared to second. So now if I run through 2 is not greater than the max. So I won't do this. It won't redefine any of these. But it will also run through this test case in which the test of 2 is greater than second, which it is. So second will then become 2. And then this will return 2. So that will, in this case, this will be correct. So.
Okay, beautiful. I still see one mistake that your code has that looks maybe kind of minor. Second to last line.
Is it this thing?
Yeah, it's above that. Yeah. Okay. Yeah. Okay. Good. So we learned something today. Do you still see failure cases in this method? I still see 1. Do you see a 2? What could somebody pass to your method that would actually make it fail?
I guess I have to think of that. If, I don't know, I guess if everything was the same element, then there wouldn't be a second biggest.
Yeah, you could argue that, and actually that's maybe a question of definition that you could have asked in the beginning, which is if you have, let's say, 1, 1, 1, there's arguably no second biggest because it's all 1, and that's something that that you would have to ask in terms of the definition to figure out what that should be. The other one that I can see is if you pass a list with just one element.
I see. Yeah.
Well, with an array out of bounds exception. Do you have, what kind of exception would you throw if you were in that situation? Let's say you add an if statement in the beginning and you check it has to have at least 2 elements. What exception would you throw?
By exception, do you mean like an error, or do you just mean?
What type of exception in Java would you?
I'm not sure. If I was testing for if the list is big enough to have a second biggest, I guess I could return something along the lines of the list not being big enough, but I don't know the specific exception to be.
Yeah, that would be an illegal argument exception mostly.
Oh, okay. Okay.
Good, but okay, let's work through some questions, and it might be that I didn't spot an error case. I think this looks fine to me at this point, but it might be that I didn't spot an error case that somebody else saw. But first, let's ask a question from Shri. So Shri, you asked, we can generally choose which language to program in, right? That is correct. You can choose whatever language you want. You just communicate it to the person that arranges the interviews. Second one, looks like you might need a nested loop. That is an option, but we're going to get to that in a second. I think in that case, we're going to move on. I think this looks good to me. What is the runtime complexity of this?
I guess it would depending on the size of the list, it would run for longer, so it would be a linear time. So, some O of n.
Okay, that sounds good. Can you think of another way of writing this method that might be less error prone while being while being worse in terms of the computational efficiency?
I guess. Well, I heard something about that nested for loop. I'm trying to think of the way that you would do that, but something along those lines. I don't know exactly what to do with that right now. But if you had a nested for loop, I guess you could compare one index with the rest of the list, and then go along the list and compare with the rest to find some sort of max in second. But I don't have the details in the code for that. But I guess that would be computationally inefficient, I guess.
Yeah, so the option that I can think of right now would be you just use arrays.sort in Java to sort the array line of code.
Yeah.
That gives you n log n complexity, which is not that great. But then you just return the second element of the sorted array, and you would have traded the fact that you now have 2 lines of code instead of 10 lines of code into having worse computational complexity.
Yeah.
And this is a somewhat typical trade-off. Oftentimes you actually need to decide whether you want to have more readable code, or whether you want to have code that is maybe a bit less efficient.
Okay.
Okay, well, thank you, Andy, for volunteering. And I'm going to, I'm going to ask the second volunteer for the second question. Who's that? You are?
I'm Andy, too.
Also Andy?
Yes.
Okay. Okay, hi, Andy. So the second question that I have for you, second question is, we have this beautiful little map that contains villages that are spread in this rectangular grid, and each little green dot is a village. And we have this little blue spot that represents the point where that has the least total distance from all the villages. As you can see, it's right in the middle here, and that's because my arrangement is very convenient. Yeah, I'm going to hand it over to Andy to ask some, actually no, I'm going to let everybody think for 30 seconds about clarifying questions, and then I'm going to let Andy ask some clarifying questions. Great. Well, Andy, any clarifying questions?
Does it matter what the input looks like for the method? Like an array of arrays?
Yeah, that would be a fine option. In general, you can, propose something and then see if the interviewer goes with this. So in this case, an array of arrays of integers is a fine choice for that. How would you represent the villages in this array versus the empty spaces?
Well, it would be a array, and then for each index of the array would be another array with the coordinates basically for each village.
So you have a two-dimensional array, but what would be in the fields of the array, of the inner array?
So you would have for the four different villages, and then you would have one village with its X and Y coordinates in an array, and then the next village. Like,
okay, that is a good option. Okay, let's do that then. Okay, so we have basically an array of positions, and each element in the outer array is going to have a two-element array in it, which denotes the X and Y positions. Okay. Yeah, that is a fine choice. Okay, so let's give everybody 30 seconds to write down the method header, and then, oh, actually, no, sorry. Do you have any other clarifying questions before we proceed?
is it okay if I return an array with the coordinates of the best location?
Yes, that would be an array with two elements, one being the X and one being the Y, no?
Yes.
Okay, yeah, that is perfectly fine. Other clarifying questions?
I think that's it.
Okay, then I'm going to give everybody 30 seconds to write down their method headers. Good, beautiful. Go ahead, write your method header.
Okay. So I'm gonna have an array of integers be the output, and then it will be best location, and I'll take in the array A, which is the input. And then am I good to continue?
Wait, does that actually look like valid Java syntax with the A in the parentheses? Yeah, perfect. Okay, and then let's first think 30 seconds about our algorithm for solving this, and then I'm going to talk to you about the algorithm that you chose. Okay, let's get going. What is your algorithm?
Okay, so for the array that will be returned, it will include an int variable of the X location, which for now I will set equal to 0, and then the int variable for the Y location, which will also be set equal to 0. And then in order to find the most ideal location, I will be using an int called smallest distance that I will set for now equal to 100, just because it's bigger than the other possible distances just for a base value. And now, I'm already running out of space. I will be using a for loop.
Okay, let's wait. Let's actually talk about the solution so I can understand your solution before you start writing. This is very important. Actually, let me just go on a quick monologue here. So there are 3 points where your interviewer can tell you that you're wrong. First point is when you regurgitate the problem. If you provide an independent example of your own, or if you explain how the example would produce a certain output, that's the first point. Because if you're not understanding the question correctly, then the interviewer can tell you at that point, look, you're not understanding it. Second point is writing your method header, because when you write your method header, you have to make it clear what the inputs and outputs are. And typically, if you have a right method header, you're somewhat on the right track. At least you're not solving the entirely incorrect problem. And the third one is when you present your algorithm. But what you're doing right now, where you're starting to write the code before you have your algorithm done, is kind of robbing yourself of the ability to verify that your algorithm is actually correct before you start writing code. Okay. And writing code takes a lot longer than explaining an algorithm typically. So, what is your algorithm? Describe it in human words.
To find the smallest distance, I was thinking a for loop to go through the different y values in the grid, and then inside of that another for loop to go through the different x values, so you can hit every possible location. And then inside of there, I would call an int. For the total distance for that specific location. And then after I call that integer, I would call another for loop to go through the input array and find the difference between each village's location values and the current location values. And then I would add those to the total distance. And then I would check if the total distance is smaller than the smallest distance. And if it is, then I would replace the smallest distance with the total distance and then set the x location and the y location equal to the current x and y value from the for loops. And then I would return in the end of the method, I would return an int array with the x location and the y location found throughout the whole for loop or nested for loop.
Okay, that sounds like a reasonable approach. What would you choose to be the range for your x and y?
I would choose the number of rows and the number of columns. Yeah.
So that kind of so in my example, let's say we have a grid with 10 by 10 or so. Your x would start at 0 and would go to 9 or 10. And then your y would start at 0 and it would go to 9 or 10?
Yes.
Okay. Let's go with that, and then we'll talk about potential trade-offs with that afterwards.
Okay. So go ahead and start writing that.
And for now, let's assume that you have a magical method that gives you the total distance given a point x and y and your input array A of towns on the map.
Okay, so assume there's already a method that finds the distance based off of the x and y values?
Yes, correct.
Okay. So I will have a for loop that takes an int y that's equal to 0, and y will be less than or equal to the number of rows that's in the grid, and then y will increase by 1 every iteration. And then after that, I will have another for loop that will take an int x that's equal to 0 and have that less than or equal to, it'll go up to less than or equal to the number of columns. And then increase by 1 every iteration. And then once this is done, I will call an integer that is the total distance And I will set that equal to the method that will return the distance, I'll just call it distance, of the x and y values. And then after that, I will have an if function. I'm just going to move over here. I will have a if function that checks if the total distance is less than the smallest distance. Then the smallest distance is equal to the total distance. I'll set the smallest distance as the total distance. And then I will set x location equal to the current value of x from the for loop. And then y location to the current value of y from the for loop. And I'll close the if statement and close the two for loops. Sorry, the error is kind of in the way. And then I will return a new int array that contains the values of x location and y location. And then I will close the brackets or curly braces.
Okay. So this looks nice. Sadly, we won't have time to do a test run for this because we're kind of running out of time. I think, do you wanna, let's discuss some of the trade-offs in this. Is there anybody in the audience who has an opinion about the trade-offs that Andy took in developing this solution? Okay, so one of the obvious trade-offs in this is that the x and y are kind of set to the number of rows and number of columns. And they run between 0 and the number of rows and the number of columns. So, oh yeah, if you have a question and if you want to interact, please unmute yourselves. It runs between the 0 and the number of rows, number of columns. So if you have a, let's say, a field with 100 by 100, and you have one town in this thing, then it will still run through all the x's and y's, and it will take a rather long time to do that typically. The other caveat, of course, of this is, and then maybe a more functional issue is that in this case, the caller actually needs to have the knowledge of the minimum x and the maximum x and the minimum y and the maximum y. So actually, if the code was honest, it would put a number of rows and number of columns in the method header. Because right now, based on how your code is written, these would actually be input arguments. Your code isn't calculating those. Do you have a way of maybe fixing that? How would you potentially fix this so the caller doesn't actually have to supply these? Okay. Yeah, I'll just tell you a solution. So one solution would be that in the beginning you could calculate the smallest x and the smallest y, biggest x and the biggest y in your coordinates. You could actually then go and figure out what those are based on the coordinates that you get as an input.
Okay.
Yeah. The other thing is, of course, we need to implement that distance method. We're not going to do that right now, but that actually presents some interesting questions as well, because you have different ways of choosing between metrics for the distance. You could choose the traditional, or actually, what options do we have for computing the distance?
I was thinking of using map.abs to find the difference between the x and y values in the for loops and then the x and y values held in the input array.
And then you would add the x distance and the y distance together?
Right, and then I would add that to the total distance. So by the time, because there'd be a for loop in this distance method,
yeah.
And so it would go through each village location, and so each village location would produce its own x difference and y difference, and then add both of those into the total distance, into the current total distance value.
Okay, yeah. So that's one approach. That's called the city blocks or Manhattan distance, which just goes along the grid lines. It goes left one and down one. That's a distance of 2. The other option would be using a Euclidean distance, which cuts corners, which is the square root of the square of the x and the y difference. So yeah, you have different options for that. And that might have been a clarifying question as well, is which metric do we actually use for distances? Because it's not necessarily obvious. One nice thing that we see in this solution is that it has the distance method there. And this is generally a key point in many of these harder interview questions. You see that there's a lot more code here than there was in the prior solution. So this is, of course, a harder problem than the prior one. The one common pattern is that you have individual submethods that get called. And this kind of answers the question that Therese also asked in chat, which is, are there methods and functions you wouldn't be allowed to use, or is everything essentially fair game? The answer to that is yes, with caveats. So if you want to use something that is in some library, then I would, you can suggest that, and you can ask the interviewer, can I use that or not? And the interviewer will tell you if they think it's appropriate or not. And if they think it's appropriate, typically they might ask you how it's actually implemented. If it saves you a large part of solving the problem, they might ask you how it's implemented, and then you will have to explain it, but at least you don't have to write the code for it. But in a similar vein, you can just, at least in the beginning, make up your helper methods. There's no reason to actually write out all the code that is required to do the distance method. You can just call the distance method here, and later on, if the interviewer asks you to actually write the code for it, you can still do that. But the nice thing is now you've saved yourself a bunch of work, at least for now, and typically sometimes forever. Which gives you a lot more time, of course. And you've shown that you're able to modularize code, which is dramatically important in any kind of work scenarios, is that you are able to take a large problem and partition it into small problems that are easier to solve. So yeah, we learned something from this example as well, which is use helper methods whenever you can, and use helper methods before you define them. Just use them, write a helper method, say, assume that this is solved somewhere else. I can write it later if you're interested in it, but for now, let me just use this helper method. Now the solution is probably 5 lines shorter than it would have been otherwise if you hadn't used this helper method. Perfect. Well, let me see if there were any other things, clarifying questions, inputs, outputs, design algorithm, corner cases. In this case, we don't have any. I'll leave it as an exercise to the reader to find a more efficient solution than this. There is actually a solution that is linear in terms of the elements of A, which this one, but I'll leave that to everybody else to figure out, to you as well, and if you like it. Thank you for volunteering for this.
Thank you.
I'll take over the presentation again for a few closing words, and then we'll be done. Okay, so we'll go through common mistakes. First, let me reiterate something that I said earlier. I know people might not necessarily listen all the way, but and so I'll just say it again. There are 3 points where an interviewer can help you. And remember, interviewers typically want to help you. They're not all mean people that are looking for you to fail. As an interviewer, it's a lot more pleasant to see a candidate that is doing great and that's resolving all the problems. And so as an interviewer, you have a temptation to help the other person. But you can't look in the other person's head. And so in order for the interviewer to help you, you have to actually tell them what you're thinking. And there are 3 very, very, very important points. First one is regurgitate the question. When the question is asked, if you're not entirely sure about it, even if you are entirely sure about it, rephrase the question, provide maybe a different example, provide maybe a shorter example than what the interviewer gave you, and actually say, for this example that I made up, this is the solution. Okay, first one, regurgitate the question, provide another example. Second one, write your method signature first. Once you have a method signature, you have something to discuss about. If you don't have a method signature, you have nothing. Okay, so second method signature. And the third one is discuss your algorithm before you start writing code. Because writing takes a lot more time than talking. So take that opportunity for the interviewer to tell you, look, your algorithm sounds wrong. And maybe a quick small caveat on that is, if you think that your algorithm is suboptimal, it's not quite the performance that you would expect, or that you think the interviewer expects, just present your algorithm, just present your first thoughts. Don't spend more than, let's say, 1 or 2 minutes thinking about the algorithm. Instead, think about the algorithm. If you find some brute force solution and you can't think of something else quickly, then just present that brute force solution. And the interviewer will tell you whether they want you to implement it or not. But if you don't tell them that you have at least a solution, even if it's not optimal, then they can't tell you to write it down. And for interviews, especially for internship interviews, for full-time as well, but maybe not to the same extent, especially for internship interviews, we want you to be able to write code. The algorithm design is a nice thing on top, but really we want you to be able to write code. So if you spend 20 minutes thinking about the algorithm, thinking about the perfect algorithm for solving this problem, then you will have fewer minutes to write the code, which is the main thing that you will be graded on. So if you don't write code, you're not going to do well. It's just how it is. And yeah, so go talk about a brute force algorithm if you don't think of a perfect one, and also ask the interviewer for help if you really don't know how to proceed. One of the on-site interviews in my second round of interviews at Google, I had to ask the interviewer for help, and eventually that allowed me to solve the question that I would otherwise not have been able to solve. Actually, the interviewer was very friendly because he helped me without me asking. And I only learned later that it's better to ask first instead of having the interviewer get to the point where they feel like they need to help you. Any questions on that before we proceed? Okay, well then, common mistakes. Let me go. Immediately jumping into code, we already talked about this. Talk about your algorithm first, and then the interviewer can tell you what you're doing wrong. Not testing or running through an example. We saw that in the first problem. Sadly, we didn't have enough time for the second one, but in the first problem, we actually saw how running the example helped showing a problem in the code. And believe me, every time you write code, there's going to be some problem in it. It's extremely unlikely that you're going to be able to write the perfect code right from the start. Pick a simple example. Don't pick for this second largest element, don't pick an array with 500 entries. Pick one that has 3 or 4 entries, as simple as you can, and think about maybe some special cases, like an array with too few elements, or some of the elements are the same, or there are no integers in there. And you can ask the interviewer for clarification, and then they will tell you whether that's actually an allowed state or not. Yeah, think about complexity, not as important for you, especially for internships. Okay, yeah, and don't run through 100 examples, but find some concise examples that actually illustrate what you want to show. Especially with this kind of whiteboard coding, doing this a few times with a friend will really help you get much better and faster at running through examples. Because the first time you do it, it will be rather slow typically, and you won't have a good technique yet. But the more often you do it, the better your technique will become. Not writing real code, I think this is maybe more of an issue for somebody who's never done a mock interview. Some people start writing pseudocode. We want to see actual code written in an actual language, not just pseudocode. First fitting a solution, yeah, I'm not sure how big of an issue this is. Premature optimization, this is what I talked about earlier. You might think that the interviewer expects you to come up with a linear solution in terms of complexity, and you might just not be able to find that one. You might even know that there's a linear solution, but you just can't think of the brute force solution. Ask the interviewer if you can do the brute force solution, and typically they will say yes, and then you can optimize it later. Because otherwise, you might get stuck in a situation where you're trying to figure out what to do, and you spend 20 minutes just thinking about how to solve the algorithm instead of writing code. Good. Here are some resources. There are quite a few books that are linked here. I've personally done Cracking the Coding interview. I can testify that it works well. Oh, sorry. That it works well, and yeah, I always recommend that. There's Topcoder, there's LeetCode, there's a variety of platforms where you can exercise. But in order to do well in an actual in-person or virtual interview, I would very much recommend that you train with a friend. You get yourself a whiteboard, or you do it in the editor somewhere, Google Docs or some kind of online editor. But it's a very different situation from LeetCode. You have this whole interaction element where you can ask clarified questions, and the interview can provide you with help. And you don't get that if you do LeetCode. You have the question, you have the samples, and you have your code window, but you have no interaction. And it's a very different situation from being in a real interview. So yeah, take a friend of yours, choose an interview problem, one each, make sure that you understand the solution, and then do mock interviews with each other. That way you prepare yourselves for the real situation. Good. Okay, then I'll go real quick through our hiring process. As I said, right now there are a lot of roles, but it will get better again, and so this will still be useful eventually. Most companies hire very similarly. Cracking the Coding interview actually has a summary of how specifically how some of the larger companies hire, what the process is, so you can read that as well. We first do, for full-time people, we do an online coding thing that is similar to LeetCode. And then if that goes well, we have usually 2 phone interviews, and then we have 3 to 4, sometimes 5 on-site interviews that are currently done virtually, so it's essentially the same as the phone interviews. And then there's a hiring committee that reviews all the feedback and ensures that individual biases are not having too much of an impact. because the hiring committee doesn't actually ever meet the person. They just see the written feedback from all the interviewers. And based on the hiring committee, you eventually do candidate matching, where you talk to various managers that are interested in hiring you. And once the candidate matching has happened, then you get an offer and you're hired. Internships is a bit shorter. You have typically 2 phone interviews. You have a candidate matching as well. And then the packet goes to, actually, sometimes typically the committee happens before the host matching. And then, the big difference between interns and full-time is that you have fewer, actually, you have 2 phone interviews in both cases, but you don't have on-site interviews in internship cases. So the process is a lot shorter. We have these coding samples that are basically like LeetCode or whatever other coding platform you might do. So these are interesting and important. And format of a interview, typically they're 45 minutes. You have quick introduction. Most interviewers don't do a lot of introductions. Most get directly to the problem. So don't see that as a personal affront if an interviewer just tells you their problem immediately. That's not a personal thing. It's not meant to be impolite. It's just that people want to get get down to business in a sense. And then you have the actual core part of the interview, and depending on whether they have time or not, they might give you space to ask some questions. The questions aren't graded in any way, so if you don't have questions, if you'd rather take a deep breath before the next interview, nobody's gonna get mad. Skills that we're assessing, data structures, algorithms, code understanding is what it says here. I would say code writing, problem solving, and communication. So the first one, data structures and algorithms, is not as heavy of a focus for interns. And even for full-time hires, focus on the code writing less than more than on the data structures and algorithms. Explain to the interviewer what you're talking about, what you're thinking about. Okay, this is some interesting things you can look into. But this is essentially all the stuff that's in cracking the coding interview as well. So there isn't going to be anything particularly surprising. I really, really, really recommend reading and actually working through cracking the coding interview. It's essential. There might be other books that also serve the same purpose, but that one at least served me very, very well. Good. How to prepare for your interview? This is just practice. You will actually have 3 different scenarios, especially if you interview for full-time, especially if you interview after coronavirus, because the first thing will be this thing they call coding sample, which is basically you get a written problem, you get a few examples, and you have to write the code in some online editor. That one is what you usually see on LeetCode and others. The second, and it's not interactive in any way. I mean, you hit the run button, but that's all the interactivity you get. There's no communication required. And then you usually have a virtual interview through video conferencing or through a phone call. And that one, you get a shared document and you write your code, and the interviewer sees the code that you write and they can talk to you. And then the final experience is on-site interviews. On-site interviews are typically whiteboard only. So you need to train whiteboard coding as well. There are 3 different cases. First one is the online coding tool. The second one is the virtual interview, and the last one is the in-person. Of course, right now there are no in-person interviews, so one less to worry about. Good. Careers.google.com. Apply. Everything's good. Questions? Okay. Well, if there are no questions, then I'll just wrap up. Feel free to ask Dr. Holberg any questions you might have, or our friendly Career Center folks, and then you can get your questions answered.
Thank you so much, Christian. We really appreciate you taking your time. And Yeb, Colin, Brian, thanks again for joining us. And we'll get this video out to everybody just as soon as we can. Dr. Hochberg, did you have anything to wrap up?
I'll just conclude with big old thanks, Christian. I appreciate you doing this every year for us. We love it. And Brian and Yevko, I'm not sure if you're still here, but thank you so much for your time also. And students, we got a copy of Cracking the Coding Interview on the bookshelf in the computer room here. And now that Christian mentioned it 17 times, I kept track. I'll order more copies.
I'm pretty sure it was more than 17 times. Yeah, it's really immensely helpful.
Okay, well, thanks everyone.